Okay, in this video, we're going to go ahead and continue part 2 of 2.2. So we have an example here, example number 4, that is telling us to sketch the graph of f of x equals 3x to the fourth minus 4x cubed. We have to include zeros and then something called test intervals. So I'm going to show you what that means in just a bit. Okay, so here we have a couple of steps, and there's actually a third one, excuse me, below here. It says use the leading coefficient test. So this is what we saw in the previous video, where you look at the first number in front of the highest degree, so in this case 3, and then the degree of that, and that kind of tells you what the end behavior is going to look like. Okay, so for this one, okay, I can see that my n, remember n is the degree of this function, is equal to 4. So that means 4 is an even number. Okay, and my a sub n, which is that leading coefficient, is 3, which is greater than 0, which means this is positive. And according to the chart that I had on another page before this, or the other notebook, I should say, this function will have, since it's even, they're either both going to go up or they're both going to go down. Okay, since it's positive, it's going to be up. So both of the ends are going to go up somehow. Okay, in addition, since it has a degree of 4, okay, that means it's going to have at most 4 real zeros. I'm going to put that here. So at most 4 zeros, meaning it can only cross the x-axis 4 times, no more than that, and 3 turning points. Remember that the turning points are kind of like the points where it changes from increasing to decreasing, or where you have mins and maxes, and it's always equal to n minus 1. So n minus 1 in this case would be 3, because 4 is n, 4 minus 1 is 3. Okay, so that's step 1. Know more or less what the end behavior is going to look like. Step number 2 is to find the real zeros. Here it depends a lot on the function, how we're going to do that. Most of the time you can factor. Okay, so we're going to factor in this case. And to do that, we set f of x equal to 0. So 0 equals 3x to the fourth minus 4x cubed. Okay, I'm going to go ahead and factor out. I can see that they both have an x cubed. I'm going to factor out x cubed, which leaves me, oh, I did an equal sign there, which leaves me with, okay, 3x in this case, because I took out 3 of the x's. Now there's just one x, 3x minus 4. For those of you who aren't sure what's going on here, let me know, because this is kind of a real basic factoring, just GCF factoring. So let me know if you need more help on this, okay? And then from here, we're going to go ahead and set each of these individually equal to 0. So x cubed equal to 0, and 3x minus 4 is equal to 0. Okay, x cubed is kind of an easy one because you just have to cube root it. So x is equal to 0. Okay, with a multiplicity of 3, because there's actually 3 x's. So this multiplicity, remember, multiplicity is when you have repeated zeros. Okay, it's going to be equal to 3, because again, there's 3 of them. And this one, we're just going to solve. So it'd be plus 4 plus 4. So 3x is equal to 4 divided by 3. So x is equal to 4/3. Okay, and there's only one x here, so degree 1. So the multiplicity is just 1. Remember that from the previous video, that multiplicity, if it's odd, so if k is equal to an odd number, remember k is the multiplicity, that means the graph it goes through the x-axis. So it's actually going to cross it. If it's even, it's going to touch it. It's just going to be kind of like a little bump there. And we'll see that right now when we start graphing this. So let's go ahead and start. Well, I guess we can kind of make a little graph here. I kind of want to do more room here, but that's all right. So I'm going to make a little graph right here. And I'm going to go ahead and put these zeros. So I have a 0 at 0 for sure. In other words, the graph is going to cross here somehow. And I know that this graph is going to go up from here. It has to go up from here because if you think about it, if it goes more over here this way, it's going to cross again, and we don't have any zeros there. We just have these two right here. Let me circle them. Okay, and the next one is at 4/3. So let's say 4/3 is right here. And for those of us not sure, 4/3 is approximately 1.3. Okay, repeat it with the threes. So here, the graph is going to go up as well, but it might, we want to be sure. So I want to see what's going on in the middle. So let me go ahead and put my arrow. I know it's going to go through it because, again, my multiplicities are odd. So to see kind of what's going on here, what we're going to do is use something called a test interval. Now, the test interval takes these zeros, okay, and what it does is it finds values that are before the zeros, in between the zeros, and after the last zeros. So we can see more or less what the graph is going to behave like. Okay, so let's go ahead and do that down here. That's step number 3, plot test intervals. And what I'm going to do is I'm going to kind of make like a little number line here. Okay, and this is our x-axis here. So my first zero is 0. Okay, that's the one that I already found. The second one is 4/3. So our test interval for this, let me use a different color for that. Our test interval for this is going to be here on the side. I'm going to write it. So test intervals are going to be this piece right here. So between negative infinity all the way to 0, that's the first test interval. I want to see what's the graph doing here, more or less, where is it, okay? The second test interval is between 0 and 4/3. Again, I just want to see what's going on between these two numbers. And the third one is going to be between 4/3 and infinity. So what's going on over here? Okay, and the way these work is you just pick a number that falls in this interval, and then you plug it into the function to see what the value is and more or less where that point's going to be. Okay, so it's kind of like making a table, but a little bit more, I guess, notation based. And this is actually going to help you with calculus because you do a lot of this kind of interval stuff when you get to that level of math. So we're going to pick some easy numbers because we don't want to make our life difficult. So I'm going to pick -1 here. And I'll circle the ones. So here we are choosing, so choose number between is what we're doing. Okay, so -1 between 0 and 4/3. Remember, 4/3 is 1.333333. So I'm going to pick 1 because that seems like an easy number to pick. Okay, and over here on the other side of 4/3, I'm going to pick 2 because I know 2 is bigger than this one. And if this doesn't tell us enough, I might have to go a little bit further. Okay, so we're going to go ahead and plug these values into our original function. Remember, the original function is way up here. It's this guy right here. Okay, so I'm going to use that function to see what the y values are at these points and then plot them. Oh, it's kind of crooked. And then plot them so I can have a better idea of what the graph looks like. So we're going to find first f of -1, okay, which would be 3 times -1 to the 4th minus 4 times -1 cubed. So hopefully I did my math right this time. This is going to be -1 to the 4th is +1 because it's an even exponent. So 1 times 3 is 3 minus, so I'm going to have 3 minus 4 times -1 to the 3rd power. This is going to be -1 because 3 negatives make a negative. So -1 times -4 is +4, and that's going to give me 7. So that means that this point right here is -1, comma 7. Okay, so I'm going to go ahead and plot that on my graph up here. So it looks like I have -1, let's say, is over here somewhere. Okay, and 7 might be right here. So -1, 7. So far our graph looks fine. It's kind of in the right spot, and we can assure that with this test interval point that we just found. Okay, so now we're going to find a number here in between to see where more or less that lands. So we chose 1. So f of 1 equals Same thing, 3 times 1 to the 4th minus 4 times 1 cubed. That's going to give me 3, and that's going to give me 4. 3 minus 4, okay, is going to give us negative 1. So this point is 1, negative 1. Same thing, I'm going to go ahead and plot this point on my graph. Okay, so 1 is going to be pretty close to 4/3, maybe over here. Okay, so 1 and then negative 1 we'll say is like right here somewhere. So kind of like right on it right there. So far we have some points here. So the graph might be something like, I don't know, it looks like it's kind of doing something like that. There's probably some lower points here, but again, if you wanted to get a better, even better sketch, you could find numbers that are closer to 0. So maybe like 0.25 or 0.5, but we're just going to go ahead and do the basic ones for now. Okay, and then the last one we're going to check is that last interval, which is from 4/3 to infinity. So f of 2, for example, 3 times 2 to the 4th minus 4 times 2 to the 3rd. This is going to give me, let's see, 2 to the 4th is 16. 16 times 3 is 48, I believe. And then this is going to be 2 to the 3rd is 8. 4 times 8 is 32. And that's going to be, what is that going to be? 12, I think. What am I? Let me see. 8 minus 2 is 6. 4 minus 3. Oh, it's 16. What am I saying? 16. So this is going to be 2 comma 16, which means that my last point, the last test interval, is somewhere way over here. So this is 4/3. We'll say 2 is about right here. So 16 is way up here somewhere. So it's going to be somewhere like up there. So more or less our graph is all right. Okay, and if you want, you can extend that one. Okay. And there we go. That's how you do a test interval. Okay. Again, those are my points. Let's go ahead and try another one. So we have another example here. It's to sketch the graph of f of x equals negative 4x cubed plus 4x squared plus 15x. This one has a little bit more factoring involved, which is why I chose it. Number one is to use the leading coefficient test, so LCT for short. We're going to go ahead and do the same thing we did in the other one. So our n for this one is the degree, which is 3. Our a sub n is going to be that negative 4, which is less than 0, which means it's negative. Okay. And that means that the graph might be something like, since it's negative and it's an odd, oh, sorry, this is odd. Okay. That means they're going to go the opposite direction, but not this way, this way. Okay, because that's what our leading coefficient test chart told us. So one more thing, n minus 1 in this case is going to be, our n is 3, so it's going to have at least 2 turning points, or no more than, I should say. And it's going to have no more than 3 zeros. Okay, based on this right here. No more than that. Now we're going to find our zeros by factoring. So same thing as before, we're going to set this equal to 0. So negative 4x cubed plus 4x squared plus 15x. Okay, first thing I'm going to do with this is I'm going to use GCF and take out an x. So 0 equals x, okay, negative 4x squared plus 4x plus 15. Okay, and now we can see that this one right here is an easy one because if you set that equal to 0, x just equals 0. So there's already our first one. With multiplicity, remember that's our k of just 1, meaning there's only one 0 here at, not 1, 0, 1. This is just x equals 0 because there's only one x degree of 1. Okay, it's not a double 0 or anything like that. For this one, I'm going to go ahead and use my slide and divide method, which some of you still have not quite understood. So make sure that if you don't understand this method, you're paying attention here, okay? When you do slide and divide, what you're going to do is slide this over. So this negative 4 over here. but hold on to it because we still need that -4, okay? And this new function is going to become, like, I guess I should put 0, is going to become, let me see, x squared. If I divide, I'm sorry, that was the same, plus 4x, okay? And then we're multiplying, so this would be -60, okay? Oh, sorry for that. So when we slide it over, we're just going to multiply, okay? And then here we can factor. This should be a pretty easy factor for us. So we're going to have x and x. I want it to equal to -60, but I want it to add up to 4. So maybe 10 times 6, right? 10 times 6. You do have to learn multiplications for this part. And since 4 is positive, I want to make my 10 positive because the bigger one should be positive for this to come out to +4, okay? And then we're going to bring back our -4 here and divide it. That's where the divide part comes in. You want to simplify if possible. Okay, maybe we should do some of these in class. So 0 is going to equal to, let me see, x. We'll do plus, this is going to divide into by 2, so that's going to be 5/2. Okay, but it's negative. And actually, let's just put the negative right here. So leave that positive. We'll just put the negative right there. Okay, and this one's going to be x minus 6 divided by 4 is going to give me 3/2. Okay, and then from there, we can go ahead and slide this back up. Get my notebook a bit. So from here, we have 2x minus 5 and 2x minus 3. And we're almost done. We set these equal to 0, so 2x minus 5 equals 0, and 2x minus 3 is equal to 0. Add 5, so 2x is equal to 5 divided by 2. X is equal to 5/2 or 2.5, okay, with multiplicity 1, meaning there's only one x that's equal to 2.5. Same thing over here, but now we're adding 3. Divide by 2. I'm going kind of fast because I don't want it to be too long, which is 1.5. Same thing, multiplicity of 1. Okay, again, because there's only one x that we solved to get 1.5. So it looks like we have 3 zeros, which is exactly what I said we're going to have up here. We have no more than 3 zeros. Okay, so on our graph, which I'm going to do right here this time, we have a 0 at, oh, and I think I might have forgotten. Did I forget a negative somewhere? Let me just double check this really quickly. I'm pretty sure I forgot something here. Oh, right here. These two negatives are going to make this into a positive. Okay, so it should be plus plus, which makes this into a positive. So we subtract here, not add. So my answer should be negative for this one. Okay, just making sure I don't want to make that major mistake there. So it's negative 1.5. Okay, all right. We're going to go ahead and plot these points. So we have a 0 at 0. So there's 0. We have one at negative 2.5. I'm sorry, negative 1.5. So 1, 2, 3. So negative 1.5 is about right here. We'll go ahead and mark it. And then we have 2.5. So 1, 2, 3. So 2.5 is about right here. And we know that our zeros are going to do something like, our graph, I'm sorry, is going to behave something like this. So we need to fill in the middle. Okay, what does this look like? So what I'm going to do now is go ahead and use the test interval to find that. Okay. And we're going to do the same thing we did before. So I'm going to do a number line. Okay. Put all my zeros on there. So negative 1.5, 0, and 2.5. The intervals that we're testing this time, okay, are negative infinity to negative 1.5. That's this first one right here. Negative 1.5 to 0. That's the second one right here. This one is going to be 0 to 2.5. And this one is going to be 2.5 to infinity. Okay. And I'm going to go ahead and pick a few numbers to test some points. So let's do -2 here. Let's do -1 right here. And let's do 1 right here. And then for the last one, let's try 3 maybe. Okay. So we do the same thing. We go ahead and calculate f of whatever the values are. So f of -2, f of -1, f of, oh, not 0, I'm sorry, f of 1. So I'm just getting these numbers, okay, and f of 3. And we plug them into the original function, which is that -4x cubed plus 4x squared plus 15x at the top, okay? So that's going to look like the following. I'm not going to go too detailed into this part because I kind of want to get to the end result here. You'll just have to trust my calculations, okay? So we plug this in like this, and we should end up with 18. So this is -2 comma 18, okay? Same thing with this guy here. And this one's going to give us, I believe it was -7. So we have -1 comma -7, okay? F of 1, so -4 times. Plug in our 1s now. And this one, I don't think I calculated it, did I? I guess I didn't. So let me do it real quick. So this is going to be -4, because that's 1's going to stay like that. -4 plus 4 is 0, plus 15 is 15. So 1 comma 15. And then -4 with 3 cubed plus 4 times 3 squared plus 15 times 3. This one might be a little bit more calculation. So let's see, we're going to have 3 cubed is 27. Actually, let's make our lives easier for this one. Or give me a bit. Let me calculate it real quick. Okay, so for this one, I'm getting -27, which is 3 comma -27. Okay, so let's go ahead and see if all these are good to go. Let's go ahead and plot them. So we have -2, 18. So -2, 18, let's say is 18 is somewhere up here. So far that looks okay. Okay, then we have -1, -7. So somewhere down here, maybe-ish, about right there. Okay. Excuse my whiteout mess as I going a little too fast right now. Okay, so far that looks okay. Then we have 115. So 115 is somewhere maybe up here or so, somewhere right there. So we might have something like this. Okay, maybe a little more curved. And finally, 3 -27 from the bottom. So 3 is over here, and -27 somewhere way down here. I don't know, somewhere down there. So it looks like our graph is good to go. Okay, and that is okay. So in this last example, we're going to go ahead and talk about something that you're going to actually be using in calculus when you do decide to take that course, hopefully. It's called the Intermediate Value Theorem, or IVT for short. And what this theorem is if you have, let's say, 2 points, okay, so A and then f of A, so the y that goes with A, and then B and then f of B, the y that goes with B, okay, and these are on the graph of a polynomial such that they're not equal to each other, meaning the y values are different from each other, okay, then there's a number D between these y values that exists because there's a number C that exists between the x values such that these are equal to each other. So here's a better visual of what that means. Okay, here is A and here is B, and they're saying that, well, these x values have a y value that go with them. Okay, so there's f of A and there's f of B right there. Well, there has to be a point in the middle somewhere, not necessarily in the middle, but between these 2 points called f of C, which we're going to just call D, and that corresponds to whatever that C value is. So some X value is going, if I input it into the function, is going to give me this brand new Y value in between. So in theory, all that's really this is saying is if you have these 2 points on a continuous function, okay, like so, all the values in between are going to be accounted for. So here's the official definition. Let A and B be real numbers such that A is less than B. So in other words, A comes before B here on our x-axis. If in f, so if in the function f of A, so f of A, is not equal to f of B, so meaning it's not the exact same point, okay, then in the interval AB, so between this little interval right here, f takes on every value between f of A and f of B. So between this interval, there is a value between everything in these two y values, okay? And one of the good things about this theorem is that we can actually use it to approximate real zeros of a function. So the way to do this is we kind of pick some numbers, evaluate them, and if we see that the y values are going from negative to positive, well, then that means that 0 has to be in there somewhere. Okay, that's what this theorem guarantees. So let's look at an example and see how this is kind of used. It says, use the intermediate value theorem to approximate the real zero of this function right here. So what I'm going to do is I'm going to make like a little bit of a chart, okay? And I'm going to approximate some of these values here. I'm sorry, not approximate, calculate some of these values. Remember, that's just y, okay? So I can see more or less where a 0 might be located. So I'm just going to pick some random numbers. Let's try -2, -1, 0, maybe 2, let's see what else, 3, and 4. And I'm just picking some numbers here that I might be able to plug in, okay? And in here, I'm going to plug in those numbers. So this is going to be, oh, let me get a little bit straighter. This would be, for example, f of -2 equals, and so forth. And I did calculate these before, so you're just going to have to trust me on this. All right, so we have f of 2, f of 3, f of 4. And all that you're really doing is plugging this number into this one. So I'll do 1 just to kind of so you can see what I mean. So f of -2, for instance, would be -2 cubed minus 3 times -2 squared minus 2, okay? And then you just evaluate it. So f of -2 is actually going to give us -22. So we have -2 comma -22, okay? F of -1 is going to give us -6. And I guess I can write them here also. Okay, so you can see so far that these numbers, as we go closer to the positive side, they're getting smaller, okay? F of 0 is just -2. So we have 0, -2. So we're still not quite over the, so look, here's what I mean. We have -2 and -22 is somewhere way down here, okay? -1 is -6, we'll say is about right here. 0 is -2. So you see how so far our graph is doing something kind of like that, okay? F of 2 is, let's see, 2 comma -6, okay? So now it's going back down somewhere. So 2, -6 is somewhere here, so maybe it does something like that, okay? F of 3 is coming out to -2, okay? So it's back up here. Here's my -3, so it's doing something weird like that. And then f of 4 is positive 14. So 4, 1, 2, 3, 4. Once we get to 4, the graph is somewhere up here now. So at some point here, between 3 and 4, and I'm going to go ahead and kind of color, not color, but show you here, between these two numbers, we have a 0. So this is how you would use this value, because if the intermediate value theorem applies, which it does, because this is a continuous function, this polynomial function here, that means that if f of 3 exists and f of 4 exists, which they do, okay, they both have y values, okay, then there must be a value in between these two for the function that exists, okay? So I'm going to go ahead and say that we have a real 0 between x equals 3 and x equals 4. And we could get even closer. If we wanted to find the exact more approximation, what we could do is we could say, well, let's subdivide this. Let's find f of 3.1, f of 3.2, f of 3.3, until you get closer and closer to, closer to a 0 here. And that, guys, is basically it. So if you have any questions, let me know. As always, email me or send me a Google Classroom message.